Alright, well, I wanted to take a few minutes to talk you guys through the logic of a hypothesis test and why you're going to be making the decisions you're making and what the justification is behind those. So I want to start with a simple scenario. I'm not going to get a lot into the details of calculating the p-value or calculating your test statistic or anything in this. I just want to talk you through the logic. So let's say we start with an assumption, and that the null hypothesis is that H naught, right, P is equal to 0.55. And let's say we're talking about brand recognition. Oops. Sorry about that. Okay, we're talking about brand recognition. Well, H naught being such that P is equal to 0.55, the assumption is, so this is our operating assumption. Our operating assumption is that 55% of whatever the population under consideration is recognizes the brand. So if we're talking about all consumers, maybe our population under consideration is all consumers. So then we're saying that if you randomly went up to somebody, there's approximately 55% chance that they would recognize the brand, or approximately 55% of all consumers would recognize this brand name. This is the operating assumption. Okay. Say now that we want to make this into a test. The company has had some success. And so somebody at the company, one of the sales managers, thinks that the brand recognition rate is actually higher than 55% now, that more than 55% of consumers would recognize the brand. And so this is a claim, right? Whoops. Goodness. I'm having trouble writing. Okay? It's a claim, and it needs tested. Well, how do we test that? Well, we're going to take a sample, and then we're going to look at some probabilities associated with the sample. So now, in order to test this claim, one of the things I need is an alpha. And let's say we're going to use alpha equals 0.05. Okay? Now, alpha, in its truest sense, is the probability of making a type 1 error, right? But what I want to focus on here is, just from a functional standpoint, this is going to be our cutoff for making a decision. Right? It's very functional in relation to the p-value. Okay? And the whole point of the test is I'm going to take a sample and look at the probability of getting that sample under the assumption H naught is true. So this is how the procedure goes. Take a sample. Okay? And then what I want to do is find the probability of p hat being what it is whoops so we want the probability of p hat being what it is under the assumption that the real p is equal to 0.55, right? Under the assumption that in truth 55% of the consumers would recognize the brand name, what's the probability I get a sample proportion that I actually get? So what happens now is I take a sample, and let's say for the purpose of this example, I survey 100 consumers, and I find that 64 of them recognize the brand. So X is 64 out of the N of 100 consumers. So in other words, right, P hat is equal to 0.64. And so we look at that number and we say, wow, that's significantly higher than 0.55. But by how much relative to this sample size, right? You know, if the real proportion of consumers that recognize this brand is 0.55, right, then how unlikely is it that I take a sample of 100 people and get 64% of them recognizing the brand, right? Is it not that terribly uncommon, or is it very uncommon? So I need to find the probability of that. And so what I do is I calculate my test statistic. And again, I'm not focusing on the mechanics here, I'm focusing on the logic. You've got some examples in the videos and book of calculating the test statistic here, but I find that my test statistic is 1.81. And really all this is it's the z-value, right, because the sampling distribution of sample proportions is approximately normal, so it's the z-value associated with a p-hat of 0.64 is what it is. And so then the p-value, right, is equal to 0.0351, I think it was. Let me verify that. Okay, yeah, we're good on that number. All right. So the question is, what does this mean and how does it relate to the final decision that I make? So let's jump to the next slide so I can talk about that. Okay, so the p-value, what that actually is assuming, right, that the real proportion of consumers that recognize, oh goodness gracious, sorry guys, I'm having a little trouble here. So assuming the true proportion of consumers that recognize the brand is 55%, right? This p-value is equal to the probability of getting a sample proportion of 0.64 or greater out of a sample of 100 people. Okay? That's what the p-value is, assuming that the real p is 0.5. And what we're seeing is that, right, this probability is only 0.0351, or there's only a 3.51% chance that I take a survey of 100 people and get 64 or more people recognizing the brand. And that's pretty rare, right? That's fairly uncommon. And the way we actually finalize the decision is we compare that to alpha. Okay? And so what we're saying, by choosing alpha equals 0.05, we're going to say if the likelihood of seeing what we see is less than 5%, then we're going to assume that p is not actually 0.55 anymore. Okay? So 0.0351 is less than 0.05. So essentially we're saying this is very rare. Right? And there's two ways we can look at it. We can say that either, right, one way is to say you just happen to get a very rare sample. Right? The type that you only see 3.5% of the time, right? Or, right? Or P is actually, right, the true proportion of consumers that recognize the brand is actually now higher than 0.55, right? And seeing 64% of a sample recognize the brand is actually not all that rare anymore, okay? And so this is the way that we're choosing to look at it. We're going to say that this is good evidence that P is actually now higher than 0.55. And so that's why we reject the null hypothesis when the p-value is less than alpha. Okay, we're saying that, okay, this is good evidence. Then instead of assuming we just happen to get a very rare sample, we're going to assume that P is now higher than 0.55 and that 64% of a sample recognizing the brand is less unlikely than we would think. So that's the foundations of the hypothesis test. We're saying that if, right, the p-value is small, right, then we're going to view it as that's good evidence that right, that's good evidence that H naught is no longer true. Or in other words, it's also, right, another way to look at it is it's evidence in favor of H1, right? It's evidence that supports H1. We're not so much looking at it as evidence against H naught. We're saying it's just good evidence that H1 is probably what's actually true now.